Hey guys, welcome to another video of Chemistry at Home. This time we are at Casa del Smith. So I hope you're as excited to see about this much of my living room. And I'm excited to be in your living room right now. So that's awesome. Anyways, today we're going to be talking about the difference between ideal and combined gas laws. So remember when I said there's a couple ways to tell them apart, specifically three ways. And I want you to be comfortable using all three. In a pinch, if you forget one of them, you still have two other ones that you can totally nail it down. So rule number one is the number of things we give you. In ideal gas law, you get three things. Because remember, there's four variables. You've got your P, your V, your T, and your N. So ideal gas law, remember, is PV equals nRT. We'll give you 3 out of the 4, and 1 will be missing. Combined gas law, we give you 5 things. Because remember, you've got 2 P's, 2 V's, and 2 T's. Combined gas law is PV divided by T equals PV divided by T. So we'll give you 5 of those things. Again, 1 will be missing. That's what you're solving for. If we give you all 4 variables in an ideal gas law, or we give you all 6 variables in a combined gas law, there's nothing to solve for. So there's no point. So number one way, easiest way to tell them apart, count up the numbers. Now, I could say on a combined gas law problem that T's are kept constant. If I say T's are kept constant, that means I only have to actually give you 3 numbers. So this is definitely a sometimes rule. It's not an always rule. Only works sometimes. Looking at the next rule we've got, look for words like moles or grams, and realistically this slide should also say molecules, and also atoms, and also particles. Just for keeping it concise so that you guys didn't have to write a whole bunch of stuff in your notebook, I just wrote down moles or grams. If moles or grams are mentioned, you know it's an ideal gas law. If they're not mentioned, first off, make sure they don't say particles. Make sure they don't say molecules. Make sure they don't say atoms. If they don't say anything about that, it's combined gas law. PV over T equals PV over T. So no mention of moles, no mention of amount of anything is what you're looking for a combined gas law. And if you do see that, it's gotta be ideal. Okay, last thing is more of a actually reading the problem thing. This one requires the most effort, but it's also the best way to tell. In an ideal gas law problem, the gas will not change. It'll just be asking you a question about another specific aspect of that gas. Versus in the combined gas law, you'll see words like heated, cooled, changed even, compressed, expanded, pressurized, or depressurized. These are all words we can throw at you to help tell you, hey, this is a combined gas law problem. Pay attention. It's going to have a word telling you that the gas is changing. So, 3 things versus 5 things, that's rule number 1. Moles mentioned or not mentioned, that's rule number 2. And the gas is changing or the gas is not changing, that's rule number 3. Let's get into an example problem. This example problem, I want you to take a moment and try this out on your own. And while you're doing that, I'm going to draw you a picture on this screen. But I'm going to do it with no hands. Okay, hopefully you pause the video if you need more time. Otherwise, I'm going to dive into it. How much volume would a 3.97 mole gas sample take up if it has a pressure of 5.87 atm and a temperature of 457 Kelvin? First thing you need to do here, is it ideal or is it combined? And the answer is, it's an ideal gas law problem. How do I know? Number 1, I know that it's got 3 things. Number 2, it just asked me about the volume. It asked me a more specific detail about the thing. It doesn't say anything about the thing changing. And number 3, we see that word moles in there. So those are all 3 ways that we can tell that this is an ideal gas law problem. Okay, what I'm going to do on the side here is I'm going to write down the pressure, what it equals, the volume that we don't know it, the N is 3.97, the T is 457, and we have a choice of 2 different R's we can use. Remember, R is a constant, so that's never going to be a variable. This is going to be a number you need to know, and it's in the back of your periodic table. So we have a choice between the 0.0821 number or the 8.314 number. One of these uses ATMs, the other uses kPa. So in this case, we're using the 0.0821 latim per molk, liters atmospheres divided by moles Kelvin. That's the number we're using. And we're doing that because our pressure is in atmospheres. If you want to convert this pressure and then use 8.314 because you think it's a nicer number, you can do that. It's just a lot more work. But you could do it. Feel free to do so. Okay, I'm going to go ahead and set this problem up now. So here's my equation. I always write that equation first. PV equals nRT. I spaced it out so that this next part would look pretty nice. And it totally does. Here are all the variables that I have on the side here. Now they're just in their proper place. So P, that was my ATM. That's how I knew it was P. N, because it has moles next to it, that's where 3.97 goes. R, because it's a constant, and I know that I'm using the ATM constant. And then T, because it's in Kelvin. Something you guys have noticed about temperatures is that we tend to not give them to you in Kelvin. We tend to give them to you in Celsius. So be ready for this. In terms of solving this problem now, we want to get V by itself. Everything in algebra is all about variable isolation. So to get V by itself, we can multiply these three numbers together, the N, R, and the T numbers together if we want, but really we just need to divide this 5.87 over. So I didn't show any of the math here. I didn't show any of the multiplication happening, but it's there, right? I just kind of took that number and then swooped it over. When you multiply all the numbers on top, divide the numbers on bottom, you get an answer. That answer is going to be, right down here in the bottom, 25.4 liters. Great. Well, I hope you had a bunch of fun learning a little bit about gas law problems. I hope you had a great time, and we'll see you next time. So for now, peace out, have a great rest of your day, and try the review.